This is really just about a fun little project that I did in 24 hours, and then it sort of got some momentum and people were interested in it. I wrote it up as a blog post that hit the top of Hacker News. Lots of people were like contacting me and saying, oh, could you add this feature and that feature? I was like, whoa, I only built it in 24 hours. It's just a proof of concept. But like most things that you build, like very quickly, there's like a long tail behind it of all this time, like it's been kind of going in your head, and you think, oh, is there something there? You know, should I try it out? And I'm glad I did, because it was a lot of fun. So let me tell you about it. And it all starts with a good cause. So in April, Cancer Research hosted a 100 push-ups a day challenge. Not 100 push-ups in April, but 100 push-ups per day. And I thought, oh, I need to move a little bit more, so I decided to sign up for that. And then almost instantly regretted it, as you do. For those who don't know, Cancer Research is the world's largest independent cancer research organization, and they run campaigns and they raise awareness through events like these, and they're funded by the public and charity donations. And like many of you, unfortunately, I know people who are affected by cancer, so that gave me the motivation to get up and do some reps. So the first step, obviously, was not to actually do any push-ups. It was to go to the App Store and see if there were any apps that were going to help me keep track of how many push-ups I was doing. And I don't know about you, but I quickly felt overwhelmed by the choice. Like when you go in looking for something that just does the one thing you need it to do, I feel like app fatigue sets in, and then you start to get distracted down this rabbit hole, and you forget what you were originally there to do. And maybe many of you have thought, it'll be easier to build something like this myself than actually go through and audition all of these. Some of them were very dubious. I did not need, was it 30 days to rip abs or something? That seems like a stretch. I just wanted to count the push-ups. And I wanted to do it in a fun way, because it doesn't sound like a lot of fun on its own. So I thought, fun to me means building something. I get a lot of satisfaction out of that, having an idea and see it come to life. So I started to think about this idea, how could I actually build something that would help me accomplish my goal? Could I use sensor data? I know that Core Motion is a framework that gives you access to the sensor data on the phone. Hadn't really played with it too much. I helped other people use it, but maybe there's something there. But it definitely tied into my kind of quiet hobby of learning about esoteric APIs. And that's one of the really great things about the Apple platforms, is they have such a rich foundation of developer APIs, is I feel like you could go a lifetime and never actually learn all of them. There's always something new to explore. So, and just like sidebar, this is my favorite one, if that animates. Yeah, that is the longest API on the Apple platform. It's part of the context framework, and it defines a relationship between contacts, if you need to do that. Maybe with large language models, that's going to come in handy when you want to remember the name of your father's sister's daughter. But let's avoid the rabbit holes. The API I was thinking of was this one, and I remember that it caught my attention at the release of iOS 14. I thought, oh, that's interesting. What could that be used for? And then I never really saw anybody do anything with. And it came out, maybe because it came out in 2020, which was during the pandemic, where we all figured we'd never be able to get into a room and do push-ups together ever again. So hey, let's make an API for people to count it at home. I don't know. But it's a recent addition to the Core Motion framework. And for those of you who aren't familiar with Core Motion, it's a framework that was built in, I think, iOS 3 or 4. It's been around there since very early on. And it provides motion-related data from hardware sensors. It's used in fitness tracking, AR positioning, gaming, a lot of the stuff under the scenes, under the hood, relies on Core Motion. And it gives you, as a developer, access to these data types. So acceleration, rotation, all that kind of stuff that you'd expect. And of course, since how you hold your phone and what you do with your phone is very personal to you, it's gated with a user allowance privacy. So the user has to grant access before you can access any of that data. And then the last piece of my idea as it was starting to form was, well, it's 2024, so I wondered, can I apply AI somehow to this problem? And there are a lot of solutions out there that use things like the visual information from cameras to analyze your movement. But I didn't really want to go down that way. First of all, because there are a lot of solutions that do that, and second of all, I belong to a generation where you don't really point your camera at yourself when you're in the gym or you're doing push-ups. It just feels a bit weird. So I thought, oh, maybe I can do something a little bit different. So I wondered if AI could help me build the idea rather than actually using AI to solve the problem. So I decided to train one. And I don't know if any of you here have experience with training custom GPTs. It's very easy and a lot of fun. I started by providing a custom GPT the Core Motion documentation. Then I crafted a prompt to help to tell it what to do with the data, how to reference it. I wanted it to be helpful, provide examples, provide information, specific information. And what that actually enabled me to do was discuss the documentation rather than treating it as a haystack. There were a bunch of APIs. I wasn't really sure how they were going to piece together. And while I could have spent and have in the past spent hours trawling through documentation, reading stuff, trying to put it together, training an LLM on that information enabled me to just ask the question in natural language, which was fantastic. Because that meant more time focusing on the problem and what I want to build. So another sidebar. That led me down a little bit of a side adventure. I got involved with an open source project called GPTsForDevs.com. There's a QR code there. I encourage you to check it out. There's dozens of custom GPTs. They are chain of thought tuned. Of course, they support the new 4.0 model from OpenAI that came out a couple of days ago. Have a look at that site and let me know if there's any specific ones that you'd like to see. It's really made a huge impact on how I develop apps and how I kind of work through this information. So, back to the original idea. I'll take you through a simple architecture diagram of the idea as it was starting to form in my head. I was following a lot of the advice that came from Adam, for example, have separation of concerns, keep clean architecture, because you never know what you're going to want to build afterwards. This is going to sound it's going to look almost overly simplistic, but it did help me get my head around the problem. So we start with a motion manager that's going to stream the sensor data, so I can encapsulate core motion and all that code into its own kind of unit. Then we've got a push-ups detector that's going to analyze that data and connect to the motion manager using a delegate pattern. And then lastly, we'll have a view that updates based on the values that it gets from the push-up detector using the new observable macro. Thought that was fun, and then I ran into some problems with that as well. There you go. So this architecture just illustrates separation of concerns. It makes it easier to test. It makes it easier to modify. Okay. The responsibilities of the motion manager is pretty straightforward. We want to start and stop sensor updates. We want to handle initialization failures, and we want to stream updates for the values that we're interested in. In this case, we've got pitch for the orientation of the user's head. So as you kind of move, we want to know when the user gets into position to perform a push-up. And then I thought of using acceleration along the y-axis for detecting dips and pushes. Some very simple code examples here are relying on my old friend, the delegate pattern, which has served me well over the years, where we just say, we call the delegate when acceleration y and pitch change. And then we update the delegate when the values change using did sets. And of course, we want to look out for things like initialization failures. Like so often, we assume something is there. For example, core motion in the simulator is not very useful because it's not there. But I'll get to that later because that kind of took me by surprise as well. And of course, you want to be a responsible citizen and ensure your updates stop to manage resources and avoid leaving your app running or leaving processes running indefinitely in the background. Next, we got the responsibilities for the push-up detector, and you can probably guess what's going to be in here. You can start and stop the analysis of sessions, interpret the data from the motion manager. So this is where we're going to have the algorithm that's going to actually detect the dip, detect the push-up, and evaluate it. Whether the user is in the prone position, and using thresholding to detect dips, and evaluate the data sync with the count. and keep track of the count. I'll just stick that in there. So here's the code where we define our thresholds, and these were just guesstimates to start with. It seemed like a good idea that the down threshold would be about -5, up threshold is at 0.25. The push-up detector then handles starting and stopping sessions of the motion manager, so that manages being a responsible citizen on the platform and incrementing the count. But this is where the real magic is, and it's like super simple code. But as acceleration data streams in, it crosses a threshold on the way down, and then again on the way back up. So we check for position by seeing if the pitch is lower than the threshold. So you're facing downwards is a -1, and if you're facing forwards, you're getting a pitch of 0. Looking straight up, lying on your back would be +1. And then we've got the responsibilities of the view, which is super simple. I wanted to keep the UI. I didn't want to get carried away with UI like all those other apps were already mature products. I just wanted to see if this idea would even work. So we need a button to start or stop. We're going to display the count to the user. I thought it'd be nice, since we were tracking it anyway, to indicate whether they're in the prone position or not. And the goal was to keep it simple. And that was the view. No applause? Okay. But here's the fun part, because once I'd figured that all out, it was time to build and run. Or as I discovered, I built and run. I was so excited working in Xcode, running code, building onto the phone. I was all good, and then I was like, I'm gonna have to actually do some push-ups now to see if this thing works. And that got old fast, actually. I gotta admit. Every time you build and run, you gotta go and do like 10 push-ups. And then the first couple times it didn't work. The thresholds were off. And then I was doing push-ups and not getting them counted. But anyway, the initial data collection, so I wanted to identify to see if I could see any patterns. Because up until now, this was all theory. I used Swift charts to visualize the raw sensor data, which was a great addition. I think in like 12 lines of code, I just had an array of values that was streaming in from the sensors, just pushing it into a chart, and I got something like that. And imagine my satisfaction when I saw like a clear pattern appear. I was like, okay, that tells me that just by adjusting the thresholds, I can actually, like this idea might actually work, and I might be able to count push-ups. So then it was on to fine tuning. So I got the initial thresholds just kind of dialed in. They were based on the observed data. So if you look on that, I don't know if you can see the blue chart data, but it looked like a positive +5 and a -1 constituted a dip, like a full push-up. And then I had to like validate it, which meant lots of push-ups, and then fine-tune it. And the numbers that I arrived at, if that's updating, they weren't far off the original guess, 0.4 and -0.7. And when I had them at 0.5 and -1, I had a lot of kind of false positives and things. You get things like as you were getting into position, it would suddenly count that you were doing push-ups. Or if you didn't dip all the way down with your nose to the floor, it wouldn't pick it up, which again, I didn't think it was fair. So here we go. So here's bringing it all together. I'm not going to actually do the push-ups, but my wife took a video of me doing them to prove that it works. And when it comes into focus, that's pretty good. Thank you very much. So bringing it all together. The experience was really fun, building, using AI, going back and forth with a custom trained GPT, asking it questions, why doesn't this work, what can I do, asking it to explain things, helping me put this presentation together. So after I had the whole chat history of going back and forth, I could say, hey, can you just do a summary of my conversation so far? And it said, yeah, you started out with an idea to do a push-ups thing, then we did this, then we did that, then you refactored it, then I gave you the algorithm, and then, so real-time tracking really does feel like magic. putting the headphones in and performing push-ups and seeing an app update was a little bit weird because we're so used to it and we take for granted that we always interact with our devices like through touch or pressing a button or some sort of action. So to actually just be like over here doing push-ups and seeing a number updating over there was cool. And the app, the app updates without any interaction. And it's simple but effective. You know, I think this was a good kind of case study of taking an idea, staying focused, and kind of seeing it through to validation and so on. As you can see, that the app is not really going to win any awards, I don't think, in terms of UI or design. But I could have spent the same amount of time designing variations and never testing if it would even work. So, a couple of key learnings from a developer standpoint. These devices stream tons of data. It's insane how much. If you try and write it, it will lag. So I ran a similar sort of motion tracking thing while I was on a train, and my phone just lagged like literally minutes as the data was streaming in. So you need to like pace yourself. There's also some latency. So on the CMHeadphoneMotionManager API, unlike the Device Manager API, you can't adjust the update interval. So you have to do that a little bit manually. Maybe in a couple of weeks there'll be an update, who knows. But it definitely proved the importance of validating early and leaving that enhancement to later. And it was personally satisfying and fun. So I hope you enjoyed the talk. And then the last thing is, I got some QR codes there. I wrote this all together in a blog I mentioned before that I went on Hacker News. So that's the first link there. A few people off the back of that article asked for the codes to be made available. It's not going to win any awards, but it's there on GitHub if you'd like to check it out. And it went through App Store review, and it's on test flight as of this morning. So please download it, check it out, do some push-ups, and thank you.